Imagine you're a high school student, just living your life and doing whatever high school students do. Then all of a sudden, you remember that Mr. Smith is your chemistry teacher, meaning that you're required to make a chemistry video about a topic that you chose. You realize you haven't even started yet, and you decide to look at the list to check what day you present, just in case. Looking through this list, you see that it's due tomorrow, so naturally, you decide to pull an all-nighter to finish the project by your due date. Pulling your all-nighter to do your research, scripting, and video editing for a 10+ minute video in such a short amount of time without falling asleep requires lots of energy, so you resort to drinking a cup of coffee to get that boost of energy you need to finish the project. Then you wonder, what is it about this liquid that gives us this boost of energy? We all know that a chemical known as caffeine is responsible, but what exactly is so special about caffeine? Before looking at the effects of caffeine, let's take a step back. What even is caffeine? Caffeine, also known as C8H10N4O2 or
trimethylxanthine,
is an alkaloid, which, according to Medicines Management in Mental Health Nursing, is any of a class of nitrogenous organic compounds of plant origin that have pronounced physiological actions on humans. The first part basically just means that caffeine can be found in plants, such as and contain nitrogen bases. For the second part, caffeine is also a central nervous system stimulant, which is a drug that makes someone more alert and energized by increasing the levels of certain chemicals. Pure caffeine, also known as caffeine anhydrous, doesn't look like this or this, but more like this. Caffeine anhydrous is derived from the plants where it can naturally be found. It's bitter, white, odorless, and comes in powder and pill form. Pure caffeine can be dangerous because the difference between a safe dose of caffeine powder and a toxic dose is very small. 1 teaspoon of caffeine powder is about 26 to 28 cups of coffee. Consuming pure caffeine is generally not recommended. So what about beverages or foods that have caffeine, such as coffee, soda, or tea? How do these manage to keep you alert and awake? After you eat or drink something with caffeine, it gets absorbed into the small intestines and into your bloodstream. Then, because caffeine is fat-soluble, meaning that it dissolves in fat-based solutions, it is able to pass through the blood-brain barrier by passive diffusion and enter your brain. So normally in the brain, a chemical called adenosine would bind to brain receptors, which is what makes people feel sleepy in the first place. Because caffeine's shape is similar to the shape of adenosine, caffeine can replace the adenosine and bind to the same receptors. The difference between this and this is that caffeine doesn't produce the same feeling of tiredness, so the person feels more focused and alert. But this feeling of concentration and alertness comes at a cost. Because caffeine occupies the receptors that were actually meant for adenosine, the brain responds by making more receptors to compensate. More receptors means more caffeine is needed to fill in the extra spots. This is how some people get addicted to caffeine. They need to constantly consume more and more caffeine to feel alert and awake. So if those people immediately cut off their caffeine consumption, that leaves all these empty receptors. Without caffeine to fill them, adenosine binds to these receptors, making them feel very tired. Speaking of caffeine addiction, can it even be considered an actual addiction? The short answer is that it's debatable, and there are lots of disagreements. The 2010 paper in the Journal for Nurse Practitioners states that caffeine meets all the requirements for being an addictive substance, including dependence, tolerance, and withdrawal. After all, caffeine is the most widely used drug in the world, but ingesting caffeine is definitely more socially acceptable than using drugs like heroin or cocaine. On the other hand, the 2006 review in the American Journal of Drug and Alcohol Abuse points out that caffeine use does not fit this profile of being called an addictive substance. Its intake does no harm to the individual or to society, and its users are not compelled to consume it. Some argue that caffeine isn't considered an addiction because the symptoms don't last that long and are a lot milder. Experts also don't want to label caffeine dependence as an addiction because it gives the impression of addictions to other drugs, like cocaine or meth, seeming less severe. This brings up another question of, is caffeine addiction really that bad? After all, what else does caffeine even do other than keep you awake? In addition to improving alertness, caffeine is also said to improve your mood by stimulating dopamine, help with migraines by constricting blood vessels, boost metabolism, and lower the chances of Parkinson's, heart disease, and oral cancers. Because we can't ever have the best of both worlds, caffeine also has its fair share of negative effects, such as causing frequent urination, which could lead to dehydration, irregular bowel movements, high blood pressure, insomnia, and heightened symptoms of depression and anxiety in the long run. If these seem appealing to you, you could find your sources of caffeine in beverages and foods, such as coffee, decaffeinated coffee, tea, chocolate, soda, energy drinks, ice cream, protein bars, drugs for relieving headaches or PMS, or you can order pure caffeine powder online. For adults, 300 to 400 milligrams of caffeine a day is regarded as a safe amount, which is the same as 4 cups of coffee, 10 cans of Coca-Cola, or 200 milligram caffeine anhydrous pills. People ages 12 to 18 have the recommended daily limit of 100 milligrams of caffeine, which is about 1 cup of coffee. What if you still want to drink coffee, but avoid the negative side effects of caffeine? The process of decaffeination is used to isolate caffeine and is involved in the making of decaf coffee. Decaffeination is not 100% effective as caffeine naturally occurs in coffee beans, so decaffeinated coffee will still have a little bit of caffeine in it, about 3 to 5%. There are 4 main ways of decaffeination, split into 2 groups: solvent-based processes and non-solvent-based processes. A solvent-based process is where caffeine is removed from the beans with the help of a chemical solvent. If you forgot, a solvent is basically a substance that dissolves another substance, called a solute. Within the solvent-based processes, there's the indirect solvent process and the direct solvent process. So in the indirect process, coffee beans are soaked in boiling water for several hours. This takes out the caffeine, as well as other oil and flavor elements. This water, filled with the caffeine, gets transferred to another tank, where it is combined with a solvent, usually ethyl acetate, that absorbs and bonds with the caffeine. The resulting mixture gets heated, so the solvent and caffeine get evaporated away, leaving just the water containing the oil and flavor elements that left the beans when they were soaked in the boiling water at the beginning. Finally, the beans are soaked in the original liquid so the oils and flavor can get absorbed back into the coffee bean. This process is called the indirect solvent process because the beans themselves never actually touch the solvent. In the direct solvent process, the beans are steamed for 30 minutes to open their pores. They get rinsed with the solvent, ethyl acetate, for 10 hours to separate the caffeine. The solvent, which is now caffeine-laden, is drained away, and the beans are steamed again to remove any extra solvent that might have stayed on them. The other 2 processes are called the non-solvent-based processes because they don't involve the use of chemical solvents. There's the Swiss water process, which takes advantage of diffusion, and the carbon dioxide process. In the Swiss water process, the beans are first soaked in very hot water to dissolve the caffeine. This water, which contains the caffeine, as well as the oil and flavor elements, is poured through an activated charcoal filter. Because the caffeine is larger than the smaller oil and flavor molecules, the charcoal filter catches the caffeine, while the oil and flavor pass through the filter. After this, we end up with two things: the flavorless caffeine-free beans and the water with the oil and flavor. The flavor water is then mixed with brand new coffee beans. So as a review, we know that diffusion is when molecules or atoms move from a place of high concentration to lower concentration. There's a higher concentration of caffeine within the new coffee beans compared to the water, so caffeine will diffuse out of the coffee bean into the water. The water is already saturated with the oil and flavor elements, so the oil won't diffuse out of the coffee bean. After the process, we end up with the new coffee beans not having any caffeine but still retaining their flavor. The last process, which is also a non-solvent process, is called the carbon dioxide process. The beans are soaked in water and then placed in an extraction vessel. Liquid carbon dioxide is forced into the coffee. The carbon dioxide acts as a solvent. It dissolves and takes the caffeine from the coffee beans but leaves the flavor behind in the beans. The carbon dioxide, which now has caffeine in it, is transferred to another container. This is generally an expensive process and is only used for large amounts of commercial-grade coffee found in grocery stores. Decaffeinated coffee is a lot safer to drink nowadays, as these methods used to extract caffeine are a lot safer compared to what was used years ago. For example, benzene was once used as a solvent, which has harmful effects. Still, caffeinated coffee is a lot more popular than decaf in general, but decaf coffee is still a good option for people who are sensitive to the effects of caffeine. While we use caffeine in foods and beverages, caffeine can also be used as an insect pesticide. Caffeine inhibits an enzyme that breaks down adenosine monophosphate, a waste product. If adenosine monophosphate isn't broken down, it will build up and overstimulate the production of hormones, poisoning the insect. Because as humans are much larger than insects, we aren't affected nearly as much as an insect would be. To summarize, caffeine is a central nervous system stimulant that heightens one's energy and alertness. When consumed, caffeine replaces the molecule that makes us feel sleepy, called adenosine, and binds to brain receptors, making us feel awake and motivated. Frequent coffee intake can result in a caffeine dependence, but in the end, caffeine can't really be called an addictive substance. There are multiple benefits of caffeine, but there are also multiple negative effects as well. If you want to avoid the effects of caffeine but enjoy the taste of your coffee, decaffeinated coffee is an option for you. There are 4 ways of decaffeination, 2 involving chemical solvents and 2 that don't. Well, that pretty much sums it up now, so now it's up to you to decide whether it's worth having caffeine in your life.